Login acceptance.
Yes, and we have it. Finally, welcome everyone on a stationary conference. Finally, after 2 years, it's much better to see, room in front of me and the speakers in front of you, rather than just a monitor and a wall from the home office. Also, this room is, fairly big, a bit bigger than my home office, which is an official name actually for my bedroom. My name is Jacek Milewski, and I will be talking about monoliths. Monoliths, guys, still we are in 2021. We're not 30 years ago on a conference where we are discussing monoliths. The monoliths are still an important topic. Even if we do have serverless and microservices, right? Why are you not on a session with the serverless? Because, it's more interesting. It's, of course, very interesting to know what serverless is, to evaluate simply whether it's a use case for you or not. But also, I think that many of us are using and building microservices, right? So this is why this topic is extremely important. I'm working in Circle K, and it's very important to mention that because, all those things that I'm presenting, I've experienced, tried, and designed within a team in the Circle K. So Business Center is actually de facto IT division of Circle K. So where we are, let's start with something familiar. We're building systems that can be distributed or not, modularized or not. We don't have actual name for monoliths. We call them those nasty monoliths we call a big ball of mud, which are not distributed and not modularized and, hard to maintain. The dream or the goal a few years ago, or even now, is to go to microservices. But this path is very difficult because we can end up with, instead of one monolith, we can end up with several monoliths, hopefully smaller, but not necessarily. So the way to go is to first modularize this thing, and later, if still this is needed, then distribute it, right? Distribution is not the goal itself, but you might have drivers in your system that can, be valid to modify your system into distributed manner, right? Like here in this room, I thought that you would be more distributed, guys. You're kind of monolith somewhere, but still the distribution, it depends on a driver, right? Whether you need it or not. I'll be talking about modularizing, so this first step, not the second one. Agenda consists of just 2 points, right? It's very short. The strategy. So first, how did we design this thing? What decisions did we take in a team, and what discussions did we have? And then the tactics. So how did we actually implemented it? I'll be mentioning a tool, and also the process of refactoring. The disclaimer is here that I'll not be speaking about how to define your modules. I assume that you know your business best, and you are able to define your modules. I'll be talking about how to, once you already have them, how to keep the boundaries and, to restrict that the architecture that you come up with is still valid in your code across all your developers, all the developers that come to your project and leave. So the long story short is, I will show you how the project was created. How did it start? It started with a perfect microservice, I would say, because it's an identity management platform for customers. So in short, it might be a login screen with some pages to manage customer data. So sounds like a self-contained service, which could be a monolith because it has some responsibility and it's working towards some goal. but it's also a microservice internally in our company architecture that is being used via APIs and also via OAuth 2 redirects. So it's also treated as a microservice because, well, other services are also customer-facing. So we're just a part of the whole flow and the whole ecosystem in the company. The perfect microservice, I'd call it, that has one well-defined responsibility. In this case, it was user authentication and user data management. And I've said and, which means that maybe it's not one responsibility, but, well, they are very tightly coupled. So it started like a perfect microservice. We've had a set of classes that were, doing this job. They were grouped into layered architecture. We've had an integration test. So we've had no unit tests, which was a very pain for me when I joined the project, because how you can have no unit tests in your project? And actually, after long discussions and, well, thinking about it and watching the integration tests that were there, turns out that you can. You don't have to have unit tests if your integration tests are fast enough, are documenting the feature, and are your safety net. And the project is small. Right? But when the project is evolving, well, then I'll continue later speaking about the unit tests too. Also, we are exposing frontend, not mentioning much that on this presentation, but important part is that, well, the front-end structure also reflects the back-end structure, right? So we have back-end classes serving some functionality, and we have front-end for that. And with this perfect microservice, small, well-crafted, and so on, we hit the year when, the whole European developers were united implementing GDPR, right? Because GDPR deadline came, and GDPR was placed in our system. It was, and it is, somehow related to user data, because it's about user privacy. So it fits, but we felt that it's something separate. We didn't yet know what does it mean that it's separate, so we simply put it in a separate package in Java code. In this package, we took a different approach to the architecture. So it still contained the layers, the controllers, services, and a persistence layer, but we were not grouping them explicitly. So the package structure was flat. All classes were there in a single SAG, in a single bag. We kept the approach to integration and unit testing. However, we started to feel that the integration test construction is getting longer and longer because, you have two modules, system is getting bigger, so we felt that something is going to change in this place. And the front-end structure, yes, again, reflecting the back-end functionality. That's not the end, because, again, you might recognize this case. We're getting yet another thing into our system, right? It's a TC, which is a short name for terms and conditions. Not important what it is this small checkbox that you check during the registration. And yeah, again, the story is similar. We felt that it's something separate, and we started to separating it again. So all the classes, or the structure is very similar to what we've seen on the left. But there's one more layer at the top, and we call this module API. So those three things that I've just discussed are right now so-called modules, and they have module APIs. Module API is a class that is, hiding the implementation details of the module, and it's exposing API. So it's a kind of facade API, however you call it, however you implement it. The rule is that this is the class, this is the thing exposing business behavior. And yeah, it's calling the module internals. It knows internal structure, and it's encapsulating this internal structure into one single class with business methods. The intention here is to use this module API whenever you need anything from the module internals, right? So you don't call the internal classes, you access the module functionality via APIs. And this is what module is. The thing that is still not visible here are unit tests, because yes, we have them, and we have them implemented in a way maybe not that traditional way how you see unit tests. So single unit test is not testing a single class. Single unit test is testing a business functionality, which is a behavior on API. So we are sure that the class that we are exposing, the functionality that we are exposing, is tested by unit test. So the module is self-contained. It's being tested. Therefore, we can freely and safely call it from different modules. Yeah, about the unit test and the module test, I have a separate presentation, which is well complementary to what I'm talking right now. Yeah, and we ended up with 2 modules and the rest, because we have, those 2 GDPR and TC modules that were a bit better crafted, and the old one which we didn't yet decide what to do with. So we also decided to modularize the user and OAuth2. A module API is an annotation that we use to, annotate the class that is in fact this module API. And the next modules, next features, next functionalities that we've had also were designed in this way. So every time we had a short discussion whether a new feature fits into one of the modules or whether this is a new module. So yeah, it's an ongoing thing. And yeah, always when you're watching Java presentations or coding or architecture presentations, there's a part of code, and also there's a part of this little thing that's in every project and it's treated differently, which is a database, right? So relational database, how does it fit into object-oriented software? In this case, we have a single deployment unit. So everything, this is still monolith, modularized, but still a monolith. So it's using the same instance of a database, which means the modules have their own tables or set of tables that are supporting the module's functionality. And the issue here is the database relationships on a database between the tables. So if you have any constraints or cascade deletes or anything implemented on a database, then you are in fact breaking modularity, and you are making it harder to distribute one of the modules later because of those hidden relationships in a database. So you don't have everything implemented in Java, tested in Java unit or integration tested. You have also a database. So if distribution is your goal somewhere in the future, then you should keep in mind those database relationships. Well, for example, once you delete a user on a database, you might delete a row in a GDPR table or in terms and conditions table, but you can't apply Java logic then. If you want to apply some dedicated opt-out functionality, then you have to call opt-out on terms and conditions module, and you can unit or integration test it. However, the performance might harm in this case because it's slower. So there are trade-offs. The future for the project, I wanted to mention it that why modularity occurred to be important and a good attempt to me, because the authentication module is going to be replaced with an off-the-shelf solution. Right? So we are not building our identity ourselves. We are using well-crafted systems. And the remaining modules might stay. So what does it mean? It means that this thing might disappear from the system. And since we have it as a module, we can easily cut it off. Of course, not that easily, because the APIs might differ. But still, we have those APIs and integration points well visible, because we see what API this module has been exposing and what it was calling from other modules. So right now, we know where we're going. We knew that our module definitions are pretty well defined and pretty well crafted. We just felt in a team what module is and how to handle it. So the current setup was working for us for a pretty long enough time, not long time, but long enough, so that we felt good with it. And we decided that it's time to strengthen the boundaries. So to enforce some rules and those things that we are checking manually on pull request and on new development, to enforce them automatically. Also to find places where we are not yet modularized, right? Because we didn't have it for day one. We started implementing modularity later, so still there are places where the boundaries are broken. And what does it mean? It means that in some places we are calling the internal implementation details, which is risky because we don't have unit tests for that. So internal implementations might change while the API is being tested and documented in unit tests. Yes, so let's start with the tooling. Is there a tool to help us, do this nasty job for us? So to automate rule checking on a new development. So we simply want a red light, red message, anything that is red, that is stopping build once we break the rules. Also, we want to do a scan on the whole code base, whether there is a place that we have to modularize. And the first thing that was pretty obvious to us, and it was loud about it, was Java 9 and its Jigsaw project. We all know Jigsaw projects because we've been waiting because of that for Java 9 release for so long. And we have a lot of books on that. And we have a lot of materials, not that much conference speeches, which was worrying me. Whether adoption of Jigsaw in a typical business project is big enough or not. So, we've decided that we will dig a bit deeper and search a bit more. Because, Java 9 and its JVM built-in concept, which could allow to, limit the size of the deployment artifact, we didn't need it, right? We needed just a modularity. So we needed to define a module. We didn't want to break our framework and our libraries that are using reflections with this approach. So there is ArchUnit. ArchUnit, which is a library as opposed to the built-in JVM concept. And it's a kind of the comparison that ArchUnit is using is they are saying that this is JUnit for your architecture. So it allows you to define a test which will check your architecture, not your business behavior, but how do you organize your classes. So you add a dependency to your test implementation, and you are building a test very similar to unit tests, which is loading all your classes from the system, is building a rule, and is checking whether this rule is met or not. So it can, for example, fail on your CI when the rule is broken. Right? So immediately see it on a code review. And of course, you see it once you develop, right? Because the Jenkins is screaming at you. Yeah, so how to build a rule? A bit small font. I hope that you can see it. API should guide you. So you take all the classes that are annotated with service and say that they should reside in a package service. Right? That's it. So one of the simplest rule that is on that first landing page of ArchUnit. Wanted to mention that, the version is 0.18, but still there's a lot of contribution on it, a lot of people and active contributors there. So we decided to go with it. First simple example, not that architecture related, but how to write a test for your coding rules. The field injection that we want to avoid, so we want to avoid outwired on a field. We have even this small warning from IntelliJ, but we want a build to fail if anyone is using a field injection. Of course, PMD can do it for you. It's just for presentation purposes. So you can build an architecture test. Architecture test, which is de facto a shorthand for defining an ArchUnit test, is to define a field that is of type arcrule and is saying that no classes should use field injection. This is something delivered by the library. So just to start with it, I used this example. I'll show what's inside on the next slide. And you might get a violation. And the violation says that no classes should use field injection because it is harmful. Use constructor injection instead. And there's a link to Stack Overflow. And a moment of pause here, it's a link to Stack Overflow, right? Not to Javadoc, not to design pattern books, not to framework documentation. It's a link to Stack Overflow. Guys, if you're asking a good question or giving a good answer, even to simple question, you might be quoted in a library. Yeah, and red message with a few classes that are violating this rule. Field injection, what does it mean? Under this constant is yet another constant, of course. But it says that no fields should be annotated with injection annotation. There you see this error message with the Stack Overflow link. And the implementation itself is in the method on the bottom. So we have arc condition, which is architecture condition on Java field. So each Java field should not be annotated with an injection annotation, which means that here in those 5 rows, you have 5 conditions on Java field that are checking if this field is annotated with Spring Auto Wired, Spring Value, Just Inject, and so on. And in the end, you have check of this condition, whether all conditions are violated or not. Another example, very simple, is to not allow system out println, so direct access to streams. And well, because we have well-crafted loggers with formatting and fields and MDCs and so on, so we don't want our logs to land on system out. There are 2 ways to define a test. You can have this field that I've shown you before, but you can also have a method which is something more similar to unit tests. And again, there is a shorthand delivered by the library, which is access to standard stream. We can forbid it simply. Let's move to something more related to architecture. So what ArchUnit is designed for. The first thing that they advertise is layered architecture. So you can write a rule, a test on your layered architecture. So architecture rule that layered dependencies are respected with a small exception. So layered architecture consists of layer with controllers defined by package controllers, by service defined by package service, and persistence with rules that layer controllers might not be accessed by any layer, because those are not things that we are calling from Java code, those are HTTP APIs. Also, the layer services may only be accessed by controllers, so we're going to the layers down, and the persistence might only be accessed by services. So this call is not allowed, right, by this rule. If you do this call, then you will get a violation, unless you are service violating rules class, and you can ignore this dependency also. So this was dedicated for a layer architecture. We have something more generic, which are slices. And slices are important because they will be modules in what I call the modules. And the slices is something more abstract, also delivered by ArchUnit. So you can define a slice as whatever you want. In this example, let's say that we have slices matching controllers. So all classes in a controller package will be named as a slice, and we define a rule that the controllers should not depend on each other, which is reasonable because we want controllers to call a domain object services, not a controller, not other controllers. For more examples, you can refer to ArchUnit example project. which is contributed by 2 developers, but is well crafted, and you have all cases presented there. Just 2 contributors, but very active. And also the documentation, where you have a graphical representation, what is forbidden, what is allowed by the given rule. So coming back to the modularized monolith thing, we do have rules, several rules that I'm going to present. And the first important rule in my case, for modularized monolith, is that, if you recall the module API, is that module API is the only place that other modules can access. So module functionality can only be accessed by its API, not by internal representations, not by silently calling a repository, just by calling API. So the rule here is to allow green lines and forbid red lines here. We've implemented the rule, we've scanned the code base, and we got almost 3,000 violations. I can promise that I had even more violations, but I couldn't replicate it once I checked out the old revision. I recall the number something around 5,000, but it's still pretty much. So let's jump into implementation of this rule. So this is my rule on the top. Again, it's in 3 lines, but it's not that simple, of course, because you have 2 variables there. And yeah, that's also a yellow, let's say, light for ArchUnit. It's not always that perfect as in documentation. But most of the things are doable, and they are not that nasty. They are working pretty nice. So we have a slice that is taken from the top-level package. We take everything from this package. We call it a module starting from now, which is a module GDPR infrastructure of NTC. And we cross out, because, well, we don't want to scan everything right from the beginning. We want to just enable next modules in turns, because, well, 3,000 violations, right? We can't enable all at once. And the rule itself. So the modules should depend on other modules via API only. Let's see what does it mean that something should be included in scan. It means that it's included in a hash set. So this is how we enable the next modules to be scanned once we are ready to do it. And this is the described predicate, how ArchUnit is calling it, which means it's a predicate on a slice, which is a predicate on a module that is checking whether module that ArchUnit is right now going to scan is included in a hash set. If yes, then go on, scan it. If not, then please stop it, ignore it, scan next module. And yes, so this is the most important line in this rule. The rest is actual boilerplate. And right now we are checking the rule. So the rule that is an architecture condition on a slice, which means it's on a module, that the module can depend on other module only via external module API. We are checking all dependencies or target dependencies from this module. So we are checking who this module is calling. We are filtering out classes that are not belonging to my project, which is Java util list, hashmap, and so on, which ArchUnit is also reporting. We are ignoring dependencies from not modularized packages. We are modularizing only business packages. We are not modularizing infrastructure, utils, commons, model, and so on. And we are actually checking the rule. So dependencies referencing classes that are not API. I'll show it on the next slide. If something is violated, then we are preparing a violation message. The violation message looks like that. So we have a class that is referenced from method in some other class, and it's a violation because it's illegal according to our architecture. So how the actual dependency check look like? Well, we have a predicate on a dependency, which means that we are checking two classes that are interacting with each other, and we are checking if target class is annotated with module API, which means that this is actual module, or is in application API package, which is another way of defining a module API in our system. That's it when it comes to the first and the most important rule, right? We wanted just that. And we get flexibility from ArchUnit far better, I think, than from what we would have from Java 9. Also, the second rule that we've written is that every module must have an API. It was not that important, but it was very nice to have, so that we are sure that if new module is being created, then it has an API that it's exposing. The implementation is a bit simpler here, because we are not checking dependencies. We are inside this one module checking if on the top there is this module API. So every business module should have an API, which means that the most important part is that the last line here, so should have API, which means that we have architecture condition there, and we have a kind of boilerplate until we reach two booleans, which are checking whether the module has API class or has API package. So we're checking if any Java class in this module is annotated with module API or has package application API. In the end, we are checking this condition and building a violation message that we are hoping to never see, but at least if we do, then we want to have it readable. Next rule, and again, here is a warning for ArchUnit. Next rule that we imagined, but we weren't able to implement because of the library limitations, is that every module API method should have a module test, which are effectively a unit tests. And the problem is that we are writing unit tests in Spock and in Groovy, and ArchUnit is not able to scan those classes. So it's not simply finding them. Once you have your unit test in Java, in JUnit, then ArchUnit is finding them, and we can assert whether every business method has a unit test for that is calling this module API. Then for Groovy and for Spock, we weren't able to do it. The rule number 4, which we keep for the future, is the internal module architecture. But why we keep it for future? It's because that we don't know what internal module architecture should be. And I think that we don't have one valid architecture for every module. And this is why probably it will never get implemented. Because, well, the modules, the benefit of modularity is that you can have a different architecture in each module. So we are not going probably to enforce one architecture for every module. With those rules that we have, we started the implementation. And the implementation was, well, a meaningful refactoring. We were not changing that much, and refactoring was not difficult, but still we had a lot of discussions on that. So during the implementation, well, our continuous integration got a new build step, which are architecture unit tests. So this is where we fire those unit tests. We were, well, convinced that we should start with the simplest and the smallest and the newest module, which means, you know, the one that we crafted recently, right? Because the recent module is always meeting the architecture guidelines that we have. So we did start with the simplest one to resolve all the problems in this first simple module. The problems that we've had, well, were of course business related. I won't mention that because they were business specific, so probably not that much interesting to you. But we found things like utility classes. So we found that we are using some UIT parser that was in another module, which was effectively not a part of this module, but rather a separate a util simply. So we moved it to utility package. Well, we found out that there are some classes that are being exposed on APIs, but are not in an API package, which means they look like module internals, but they are in fact effectively the module API. So we moved them to top. So a lot of classes were moved. So you know how pull requests look like, right? You change one class, move one class, and you have 100 of changed files. So it's impossible to review. I mean, it is possible, guys. We know that everything is possible, but you know, it's not that much convenient. So the approach was to enable the rule for the module and see the tests failing. So see the red tests and make them pass with a minimal effort. And minimal effort was just moving the classes that were reported into places where they will not be reported, right? Just to postpone the problem resolution to later. And later in the same sprint, in the same story, in the same task, to have a task to implement the fix, the final fix, to make this design working well. So the next module, the interesting part is that user repository, which was, in the user identity management, what can be the most important class in the system, right? User repository. So it was used very widely by every module. So first thing that we've decided to do is to move this to module API because, well, it shouldn't be there, right? But effectively in the code, it is there. It is an API. And we created a task to resolve and hide this repository behind the API later as a next step. We also identified yet another util that was a code smell, so, well, it was removed. Because it was pretending to be a parser, but it was throwing some business exceptions, so it was affecting the logic. And here I mentioned about this pull request with when you move one class and you have 100 of changed files because the package, because of the imports were changed. So here is where mob programming was a good technique to use because mob programming is a kind of pair programming, but you have not two people working on that, but the whole team is working on that. One person is writing a code, rest of the people is discussing and watching. So preferably the whole team is watching. If the whole team is watching, then you don't have to do the pull request because we were all implementing it, right? So why would you want to review it later? This is how we avoided those bloated pull requests. And it's a very good case when you have more things to discuss than to implement. So, moving a class is a 5 seconds job in IntelliJ, but discussions around that, it might take even half an hour. Half an hour is not that much if I'm thinking about it today. Yeah, so other simple modules, and we again moved some classes, which led us to the conclusion that then somewhere in the middle, it started to get boring because all problems were already resolved, right? And the next modules that we've enabled and scanned were pretty similar, had a similar problems, which is a good news and a bad news. Good news, because we can simply complete this refactoring without further issues. It's a bad thing because it's boring, right? The interesting parts that came up were, for example, creating a new module, and you see a screenshot from a GitHub with a pull request. There's a significant number of changed files, right? 88, pretty long discussions. So creating a module from classes scattered across the code base is not that simple. And the largest modules comes last. We've resolved all the simple problems on our simple modules. Right now we can approach the biggest modules, the most important, the crucial modules in our system. So starting with small modules was a good decision. We've had some problems addressed right now, and we can tackle the bigger problems right now. Yeah, and the trap here that we've had is a cohesion, which is, let's say that we have two modules, a user and a sign-up. And the user, of course, is managing a user, and a sign-up is signing up a user, which is effectively creating a user. And both of those modules are using address class. So it seems that address is shared module between those modules. But the problem is that we have a lot of other modules which don't care about the address class, right? So seems that user and sign-up are coupled. So maybe they should be a single module, or the address is not needed in a sign-up. So it requires, more discussions that are a bit more business related, not that much code related. And yeah, are we done? Is this step that we have a modularized monolith? We are much closer to that, and this setup is working for us. So we have well-defined modules and the boundaries, and we keep those boundaries. In fact, the tool is keeping the boundaries for us. The next steps, we are thinking of submodules. If module is big enough, like user module for my case, then maybe it should have submodules like user and a sign-up, which is a submodule for that, and how to write rules for that. So rules on a module internals, whether we need ones or we can live with whatever happens in a module state in a modules. Yeah, and that's it. That's it when it comes to modularity from my side. Thank you very much. If you have any questions, then please go on. Yes?
One about the database coupling on the modules level, because monolith spread on the same database instance. So if you had any ideas how to solve it with any tools?
Yeah, so the question is about the database. So we have modules deployed on one instance and on a database. No, I don't have tools. The only tool is if you have a database relationship, then you can test it with integration tests or end-to-end tests, however you call it. The tests that are working with a database, so with those relationships defined. So this is the only tool that probably those tests will fail if you split your database across the separate instances, right? So this is the only safety net. So good old integration tests. OK, fine. Great. We will be first for the dinner, I hope. Thank you, guys. Have a nice conference.